Hi students. So this is a 4-bit adder subtractor circuit. Okay, I have made the circuit in Logic Gate Simulator, and you can use that platform for implementation purpose. So here you can clearly observe from the circuitry that we have used 4 full adders, right? With first full adder with output sum is Q naught. Second adder full adder output is Q1, third Q2, Q3, and a common carrier output is there. You can see CYO. This is common carry output from the 4-bit adder or subtractor circuit. And in input section, we have used toggle switches. Okay, two 4-bit number need to be fed in the circuit. So for this purpose, our first number is denoted by A0, A1, A2, A3. That is 4-bit number, and second 4-bit number is fed in the circuit using B0, B1, B2, B3. Okay, so we will toggle this logic accordingly according to the number, and we input the number in the circuit. And you can also see there is a toggle switch where I have written add logic 0, subtraction logic 1. So what does it mean? And carry input is also fed through that switch. Okay, so when logic that toggle logic is at 0, that toggle is at 0 logic, so carry input is also 0. So we have discussed in the previous lecture that this will be that aux will be act as a buffer. Okay, directly B0, B1, B2, B3 will appear at the output of the XOR gate. And when logic is high, subtraction of will be performed by the circuit and carry input will be high. So for subtraction, you know, uh, 2's complement method is used. Okay, we just add one complement to first number, and again we add 1 to the resultant. So here we achieve this by adding a XOR gate, which is a controlled inverting operation is performed, right, when the logic is high. So carry input 1 is also added, so 1 is added to the 1's complement and our objective is met. Subtraction is performed in the circuit. So we will just implement here. We just take two numbers 4 and 2 and add them and subtract them accordingly. So first number is 4. What does it mean? 0 1 0 0 means our A2 must be 1 and rest of the bits will be 0. And for 2, decimal 2, binary equivalent is 0 0 1 0. So means our B1 must be high, and you can see addition is performed during this because toggle switch we have used for addition is at low logic, that is 0. So output is there 1 1 0 0 1 1 0. So this is equivalent to decimal 6. So 4 and 2 after addition is 6. So hence 4-bit addition is performed, And for subtraction, if we want to subtract 2 from 4, then we need to change the logic to subtraction 1. Okay, so just now you can observe carry output is present there. What does it mean? It means our resultant is positive. Okay, if carry output is present there, then the result we got from subtraction is positive. So 1 0 0 0 1 0. So after subtracting 2 from 4, the result is 2. So that's again verified. Okay, carry output only denotes that number is positive. But what if a higher number is subtracted from the lower number? In case we have to subtract 2 from 4, so we will check it what happens. So just input the number, first number 2, that is 0 0 1 0, means our a1 will be high and rest of the a0, a2, a3 will be 0. And for second number to be 4, what does it mean? A2 must be high and rest must be 0, and subtraction is there. So when we subtract two from, okay, this is we have to change this. We have to just make a1, yes, now it is 2, and if this v2 is high, now this is 4, now b is 4 and a is 2. So now you can check what is the result. Result is 1 1 1 0. You will read from q3. Okay, your MSB is q3, q3, q2, q1 and q0. So your q3 will just denote your sign magnitude, because our resultant is negative. Okay, so that's why this is set to high, q3 is set to high. Q3 is used for sign magnitude, so our resultant is in negative, our resultant is with negative sign. And this is in the form of 2's complement. We need to change it to get the result. So first take this 1's complement of this. So q3 will go to 0, q2 will 0, q1 0 and q0 will be 1. So this is 0 0 0 1. And now for this is our 1's complement, and for 2's complement we need to add 1 to 1. So after addition we will find 1 0, that is 2, and sign is given by q3. Q3 is high, it means negative sign, so our resultant is -2. Okay, for getting the result we need to convert it into our binary number by, because this result is in 2's complement form. First we will convert it into our 2's complement form, right? Only then it will give you the exact result, that is 2 after converting. So that is all, you can practice it. Okay, just make your circuit and implement it. I will share the circuit diagram on your WhatsApp group, so you can make the necessary connections. Here you can observe from first full adder carry out is made carry input to the second full adder. Okay, this so this is a cascaded arrangement. Okay, carry out from the first is fed into the carry in of the second. Okay, carry out from the second full adder fed into the carry in of third, and similarly from third full adder the carry is fed into the carry in bit of fourth full adder circuit, and finally the carry out is taken. So this is a cascaded arrangement of four full adders. So by this we can achieve our desired operation. And you can see at B input I have taken an additional XOR gate there, so that I have already described. This is a controlled inverter and buffer operation. Okay, so thank you, that's all for today.